This lesson is on creating line plots. We're going to use line plots to analyze data. The data we're going to use, we're just going to use an example of a test that we've taken, and we're going to use the scores of those tests to create a line plot. So the data we're going to create, we're going to call test scores. I'm just going to make up random test grades so that we can use these scores in order to plot on the line plot. The first score we're going to have is 100. A score of 90, 80, 80, 80, 65, 75, 75, 80, 90, 50, and let's say someone made an 85. These are the scores. We have 3, 6, 9, 12 scores of 100, 90, 80, 80, 80, 65, 75, 75, 80, 90, 50, and 85. We're going to use these test scores to create a line plot to analyze the data of the scores that were made on a particular test. So in order to create the line plot, we have to draw a line. And the line has to have representation of each one of the test scores. The test scores we received, the lowest test score was a 50 and the highest test score was a 100. So we're going to start out with a 50 and a 100. Then we're going to place all the test scores on the line plot. We have a 65, 75, 80, 85, and 90. 65, 75, 80, 85, and 90. So starting from least to greatest, we have a 50, a 65, 75, 80, 85, and 90. All of the test scores that were made on the test should be represented on the line plot. Now what we're going to do is we're going to mark off the scores, and we're going to place an X above each one of the scores for the number of times the scores were made on the test. So for instance, the 50 that was made, there was only one 50 that was made on the test. That 50 is right here. We've marked it off by placing a line under it. We're going to go to 50. We're going to place an X above 50. For the 65, there was only one 65. Go back to the line. We're going to place an X above 65. We have two 75s. One here and one here. We're going to go to the line plot, and we're going to place two X's above 75. We have 1, 2, 3, 4 80s. Go back to the line plot, and we're going to place 4 X's above 80. We have 1, 2 90s. We're going to place 2 X's above the 90. We have 185. So we're going to place 1 X above the 85. And then we have 1 100. So we're going to place 1X above the 100. And as we can see, all the scores are represented on the line plot. 150, 165, 275s, 480s, 185, 290s, and 100. That's how we create the line plot. Now, as we can tell, we have the majority of our grades falling somewhere between 75 and 90. We have 2 at 75, 4 at 80, 1 at 85, and 2 at 90. We're going to call the group of scores that are real close together, or the group of data that's real close together, we're going to call that a cluster. Cluster. Everything is, all the grades that are clustered in close together. Those group of scores are pretty close to the 100, but the one that's farthest away, that's just sitting out by itself, is right here at 50. We're going to call that number that sits farther out away from everything else an outlier. So we have a cluster of data real close together, and then the data that's real far away or that's significantly different from the rest of the data that we have, we're going to call that an outlier. Now, if we look at 50 and 100, we can also find that the range of 50 and 100 is simply the difference between 50 and 100, which would be 100 minus 50 would be 50, and that would be the range. So creating the line plots, all we need is a set of data. Our data that we used was the test scores. We place an X above each one of the scores, or each specific type of data, and we can create a range of the difference of the smallest number and the largest number. The outlier being the number or the piece of data that's farther away from the larger group of information. And that large group of information, or a large group of data that we have here, we're going to call that a cluster.